Do you know that Redis can be secured with accounts and passwords for authentication and with access control lists for commands and data permissions? You will learn today how do ACL work, how to implement it. My name is François, Principal Solution Architect at Redis since 2017. Until version 6, Redis only had a single anonymous default user, potentially with a single password, to grant full privileges. This security weakness is not a concern for developers who love Redis for its flexibility, performance, and other data manipulation and storage capabilities. They use it everywhere in nearly every company. This is a problem for ops and for the company's security team, but they got used to it. You might not know that Redis has named accounts with personal passwords for real authentication and access control lists for authorizations and permission management. Redis can be secured. Let's see how it works and how to implement it with a sample project. We have a single database to store orders and two microservices, one to update an order and another one to generate the invoice. This is a project, so we have one developer for each microservice, David and Dennis, a project manager, Paul, and an administrator, Angelina. The microservices and the people are all using the same anonymous account with the same single shared password. The password grants them full access to the whole dataset and to every Redis command. Everyone with this potential password can execute any command with read-write permissions on the whole dataset. When a microservice needs read-write access to update the database and another one only needs read-only access, if the second one has a bug, is corrupt, or is compromised, it can corrupt the data of the first one or even delete the data. If a contractor or an intern work on the project, they have full access and the global, simple shared password will probably not be changed when they leave. The microservices configuration would have to be changed too. It makes also impossible to track and audit who made what. Let's see how Redis 6 and later can address this data access security concern. First, assume that all connections to the Redis database are encrypted with TLS, otherwise the passwords can be intercepted. An ACL for access control list is an ordered list of rules, or ACL for access control entries. Each rule can grant or revoke a permission on Redis command, Redis key patterns, or Redis channels to a named account potentially protected by a password. Let's see how to define ACLs. An account can be reinitialized to its initial state, password enforced but not defined, without limiting rules but disabled with the reset rule. So it needs a password on allow passwordless authentication. The account is disabled. An account can be temporarily disabled with off rule or enabled with on rule. Let's enable the account. The connection succeeds. Disable the account. No more connection possible. Re-enable the account. The ACL can set one or several passwords to authenticate an account with the greater than sign for a clear text password or with the sharp sign for a hashed password. It can also invalidate one of the previously assigned passwords respectively with the less than or bang sign. All passwords can be invalidated at once with the no pass rule. Add a password to the account. No more passwordless connection possible. Add a second password to the account. The first password still works, the second password also works. Remove the first one. The first password does not work anymore. The second password still works. Rules can grant or revoke execution privileges on common command categories, respectively with the plus or minus sign followed by the @ sign and the category name. And the no commands and all commands are special keywords for -@all and +@all. Let's see. Reset the account with all key access. String commands are disabled. Limit the account to strings related commands only. String keys write and read are allowed, but not the other data types commands, and not the general commands. Grant a read-only access to string values only. The account cannot write, but the account can read. Rules can limit the available key space to glob patterns prefixed with the tilde sign. Access to all keys. Access to my keys and your keys only. All rules can also grant or revoke execution privileges on specific commands with a plus or minus sign respectively and the command name itself. Grant read-only access to string values and to XPRI informations. The account cannot write, the account cannot change the keys TTL, but it can read the value and get the remaining TTL. The rule order is important. Rules are evaluated from left to right. A rule list can grant execution on hash commands only but revoke execution on all the write commands. Grant read-only to hash keys. A write item fails. Revoke write commands but grant them afterwards. The revocation is useless and writes are still possible. So what about our example? We need to create 6 password-protected accounts with different permissions. Order update with read-write access on hashes and lists starting with orders star. Order invoices, the same but read-only. David, the same as order invoices. Dennis, the same as David. Paul, same as orders update to manually fix data. And Angelina, admin access to potentially flush the database but access to the data. Well, before going further, if you find this video useful, please like and share it in order to help people to find it. I'm also preparing other surprising contents, so please subscribe to this channel and activate the notifications to not miss them. So our order Redis database can revoke permissions on all commands, but grant permissions on all of the hashes and list manipulations command, excluding dangerous command, on keys beginning with order column star, to an end account order update, identified by a secret password. The first microservice can connect with its own credential, is limited to the needed command and the needed keys. The order invoice microservice needs the exact same permissions, but without any write command. So the ACL would be the following one. Now David and Dennis need to have the same read-only permissions, and Paul, the project manager, needs to be able to change values. Finally, Angelina needs a full admin access to potentially flush the database. Disabling and limiting the default account. The default anonymous account is a fallback to grant permissions when no authentication occurred or succeed. This account has to be limited. So it can be completely disabled. It is still enabled but can only execute the auth command to authenticate as another user. From that point, the only admin still available to change the permissions is Angelina. Let's test. When the project grows, application developers, project managers and admins are uniquely identified with their own credentials and have specific permissions on the database and on the data. But what happens when microservices are added with their own database, with developers moving from a project to another, with new hired people, leaving people, with another Redis database used as a message bus to communicate with PubSub between all microservices? Well, it's a pain to maintain, and Redis can also manage such situations with a role-based access control RBAC explained in my next content. So while waiting for this next content, you can find more information on this topic in the description with links. Thank you for watching. I wish you a wonderful day. See you next week. If you found this video useful, please like and share it. If not, thumb it down. This is useful for me to tune the content and for others to find it. If you want to learn more, please subscribe and get notified. You can also support me on Patreon and Tipeee. Thank you.